All right, in this example, we're looking to show that the group of 2D vectors under addition is isomorphic to complex numbers under addition. So we've got two infinite groups, so we're not going to use a Cayley table for sure to show this. So let's first start thinking about our groups. So we could have our first group be all the vectors that are some xy, and we've got that over addition. So this is, we're going from real number squared. So we've got x dimension, y dimension of real numbers. And our second group is the complex numbers. So that's going to be some x plus I, y. And we're also looking at addition as our group. Let me put this here. So this is our complex numbers. And we know that we want to have some sort of function that's going to take our real number squared and map it into our complex numbers. So we don't need to actually define what our function is. We just need to look to see that f of some a plus b is the same as f of a plus f of b. So again, real number squared is going in here, and our complex numbers should be coming out here if we want to show that they're the same. All right, so we need two different vectors here for our a plus b. So I'm going to use x1, x2, y1, y2. So our first vector would be x1, y1. And we're going to add that to x2, y2. Okay, so here I'm looking at the left-hand side. That's going to give me f of x1 plus x2, y1 plus y2. And then if I map that into the complex numbers, I'm going to have x1 plus x2 plus I y1 plus y2. All right, so now let's look at the right-hand side. So I'm going to take this, shrink it down a little bit. Okay, so looking at our right-hand side, now I'm putting in my complex numbers. So f of x1 plus I y1 plus f of x2 plus I y2. Well, what I'm going to come out of this, I'm coming into my complex numbers. And of course, I can rearrange these to put the imaginary parts together and the real number parts together. And what I can see is that my two groups have the same structure. So going from f of a plus b is the same as f of a plus f of b, going from my vector space addition to complex number space addition. So basically what we're saying is that it's a similar idea adding vectors and adding complex numbers. In complex numbers, we add the real parts and the imaginary parts. In vectors, we add the x coordinates and the y coordinates.